Hello everybody, welcome into another lesson. So today we are going to do absolute value equations. So here we have our first example. The absolute value of m minus 6 equals 8. Well, what do we remember about absolute values? You're going to usually get both a positive and a negative answer for m. Now, I mean, you may get both positives or both negatives depending upon what the numbers are, but the idea is you want to find an answer to m that is 6 units away from 8 in either direction of 8, to the left of 8 and to the right of 8. So to solve absolute value equations such as this one, you're just going to take plain old m minus 6, set it equal to 8, and you'll have m minus 6 equal to negative 8. So whenever you go to solve an absolute value equation, you'll set that what's inside the absolute value equal to what's on the right hand side, and then you'll set what's inside the absolute value equal to the negative of what's on the right hand side. So now we just solve these equations here. So m minus 6 equals 8, that means one solution is m equals 14, and then you're going to have m minus 6 equals negative 8, which would give you m equals negative 2. So and if you stick these in, the absolute value of 14 minus 6 does equal 8. The absolute value of negative 2 minus 6 also equals 8. So therefore, m equals negative 2 and 14. Those would be your two solutions to this equation. M would equal negative 2 and 14. So absolute values aren't terrible. But there's also absolute value inequalities, which we'll get to in a minute here. Let's see, similar one. We have the absolute value of k plus 7 is equal to 3. Whoops, I wrote in blue. Oh well, I'll just do the rest in black. Okay, so we have the absolute value of k plus 7 equals 3. Well, you'll just take your k plus 7, set it equal to 3, and then you'll end up having k plus 7 is equal to negative 3. So you get k plus 7 equals 3, and then k plus 7 equals negative 3. So now just solve these two equations. K plus 7 equals 3, that would give you k equals negative 4. And then you would have k plus 7 equals negative 3. That would just give you k equals negative 10. So your two solutions to this equation are k equals negative 10 and then negative 4. So those would be your two solutions to this equation. And you could always put those numbers in to check out the result, and you would see I'm right. All right, what do we got here? See, the absolute value of 3 plus x is equal to 5. All right, so we have the absolute value of 3 plus x is equal to 5. So how we're going to solve this, again, set your 3 plus x equal to 5. So that'll be one part of it. Set 3 plus x equal to 5. And what you'll do next is you'll set your 3 plus x equal to negative 5. And then now just solve each equation. 3 plus x equals 5. That means x equals 2. And then you'll have 3 plus x equals negative 5. That would have to mean x equals negative 8. So your two solutions to this equation are x equals -8 and then 2. And that would be the answer to this, x equals -8 and +2. Alright, let's do a few absolute value inequalities. So, let's see here. We have the absolute value of r is less than 2.5. So we have the absolute value of r is less than 2.5. Okay. Well, when you solve these, so this is going to come in handy in a second. Less than and greater than, we'll say greater and, duh, greater than would be or. How you remember this is you could think of less than and greater than, greater. Where this comes into play is whenever you have a less than, you're going to have, of course, r is less than 2.5, less than and r is greater than -2.5. So how this is going to work then, when you have a less than, or if it were less than or equal to, they're similar. The only difference is one includes a solution, one does not. If it's less than, you're going to take whatever's inside of that absolute value, keep the original inequality sign with what's on the right hand side, and then you'll take what's inside the absolute value, flip the inequality sign, and take the negative of what's on the right hand side. So you have r is less than 2.5 and r is greater than -2.5. Well, we can actually put this into a combined inequality. You can leave your answer like this, but if your teacher wants a combined inequality, because that's what you'll get when you have ands. If you have an or, you won't, but whenever you have an and, you're going to get a combined inequality. R is greater than -2.5. That means -2.5 would be less than r, and then we know r is less than +2.5. So what you would really get here is that -2.5 is less than r, which is less than 2.5. That would be your combined inequality. That would be the answer to this. And I got more here. Alright, what about the absolute value of s is greater than or equal to 1.5? So I have the absolute value of s is greater than or equal to 1.5. So here's what you're going to do. You're going to take what's inside the absolute value, s, keep your original inequality of greater than or equal to the 1.5. Now, this is where it gets tricky. If it's greater than, you're going to use or. You're going to take the absolute value of s, you're going to take what's inside the absolute value, flip your inequality sign to less than or equal to -1.5. Whenever you have an absolute value and you have greater or greater than or equal to, you're going to get that disjoint set. You're going to have a disjoint set here. So that's really all you're going to have, is s is greater than or equal to 1.5, or s is less than or equal to -1.5. That's all there is. There's no other way to write it. So remember, less than and greater than when solving absolute values. And yes, there's plenty more where that came from. Alright, what do we got here? Oh, good. Here we go. We have the absolute value of y plus 5 is greater than 8. So the absolute value of y plus 5 is greater than 8. Well, you're going to take, of course, your y plus 5, keep the original inequality of greater than 8, but remember, greater. So you would use or, then you'll use y plus 5 is less than negative 8. So then you just take what's inside the absolute value, flip your inequality sign, and do negative what's on the right-hand side. So now we have y plus 5 is greater than 8, or y plus 5 is less than negative 8. Now you just solve these two inequalities. You'll end up getting, for the first one, y is greater than 3, or y is less than negative 13. And that would be as far as you could go with this, since you have a disjoint set here. You have y is greater than 3 or y is less than negative 13. That would be your solution. All right. Absolute value of t plus 4 is less than 10. So we have the absolute value of t plus 4 is less than 10. Well, again, you're going to take what's inside your parenthesis, inside the absolute value, of which would be simply t plus 4. You're going to keep your inequality sign of less than 10. And then since it's less than and, you'll have t plus 4 is less than 10, and then you'll have t plus 4, you'll flip the sign to greater than negative 10. So you have two inequalities of t plus 4 is less than 10, and t plus 4 is greater than negative 10. So now solve your two inequalities. T plus 4 less than 10, that'll give you t is less than 6, and t plus 4 is greater than negative 10, that would give you t is greater than negative 14. So now you have t is less than 6 and t is greater than negative 14. Well, if t is greater than negative 14, that means negative 14 is less than t. And then we know t is less than 6. So you'll get the combined inequality for your answer of negative 14 is less than t, which is less than 6. So whenever you have a less than and then it turns into and, which it always will with absolute values, you get a combined inequality, a conjoint set. Now if t plus 4 were greater than 10, you would be using or, and then you would have a disjoint set. So those are things to bear in mind. All right, let's see here. What are we going to do now? Let's do I think we'll see here. Let's move on to some products. So let's say now you have the absolute value of something like 3x is equal to 12. So you have the absolute value of 3x is equal to 12. Well, Good news is, whenever you have a product inside an absolute value, it is identical to the product of the two absolute values separately. So the absolute value of 3x equal to 12 is the same as the absolute value of 3 times the absolute value of x equal to 12. We know the absolute value of 3 is what? That's 3. So you would get 3 times the absolute value of x equal to 12, which now you can divide both sides by 3 to get that absolute value of x by itself. If you do that, you get the absolute value of x is equal to 4. Alright, so now we're reduced to the absolute value of x equals 4, which means now you're going to have two solutions. You'll get x equal to 4 and x is equal to negative 4. So therefore your two solutions of x are going to be negative 4 and 4. That would be it for your answer. X would equal negative 4 and positive 4. All right. Let's see. We have y over 4 is greater than or equal to 1. So we have y over 4 is greater than or equal to 1. Well, we have a product rule. Y over 4 is the same as 1/4 times y, is it not? So we can take these products separately of the absolute value of 1/4 times the absolute value of y and make those greater than or equal to 1. Well, the absolute value of 1/4 is just 1/4. So you get 1/4 times the absolute value of y. That'll be greater than or equal to 1. Now we just multiply both sides by 4 to get the absolute value of y by itself. So then if we do that, you'll get the absolute value of y is greater than or equal to 4. All right. Now we're reduced to the absolute value of y is greater than or equal to 4. Well, we have great Tor. So what you're going to have is you'll have y is greater than or equal to 4, or y is less than or equal to negative 4. And that would actually be your solution. Since it's a disjoint set, you have great Tor, so it would be or. You'll get y is greater than or equal to 4, or y is less than or equal to negative 4. Alright, let's step it up a notch here. So we have the absolute value of 4d minus 11 is less than or equal to 3. So we're given the absolute value of 4d minus 11 is less than or equal to 3. Well, you'll take what's inside your absolute value and keep the sign, so you'll have 4d minus 11 is in fact less than or equal to 3. And then less than and. So 4d minus 11 is less than or equal to 3, and 4d minus 11 is greater than or equal to negative 3. That's what you would get. For the second part, you keep and, you do and, then you keep what's inside the absolute value, flip your inequality sign to greater than or equal to negative 3, the negative of what's on the right. Now we just got to solve these two inequalities. So 4d minus 11 is less than or equal to 3. Well, that's going to give you 4d is less than or equal to 11 plus 3, that would be 14. So you get 4D is less than or equal to 14, and you would get 4D is greater than or equal to, what's 11 minus 3? It's 8. No, 8. What am I saying? It's 5. 11 minus 3, that's 8. Excuse me. I can't count today. I can't add today. Ugh. Yeah, so positive 11 minus 3 is 8. Alright, so we have 4D is less than or equal to 14, and 4D is greater than or equal to 8. So, now for this part, the 4D is less than or equal to 14. Just divide both sides by 4. You'll end up getting D is less than or equal to 14 over 4, which reduces to 7 halves. So D is less than or equal to 7 halves, and then you do 4D greater than or equal to 8. That would be D is greater than or equal to 2. So now you have D is less than or equal to 7 halves, and D is greater than or equal to 2. Well, 2 is definitely smaller than 7 halves. If we have an and, we're going to get a combined inequality. So if D is greater than or equal to 2, that means 2 is less than or equal to D, and then D is less than or equal to 7 halves. So the answer we should get for this is 2 is less than or equal to D, which is less than or equal to 7 halves. All right. I think we're ready for one last one here. This time we have the absolute value of 5h minus 2 is greater than or equal to 8. So we have the absolute value of 5h minus 2 is greater than or equal to 8. Well, it's going to be 5h minus 2 is greater than or equal to 8. That's going to stay. But greater than, so it's going to be or 5h minus 2 is less than or equal to negative 8. That's what you would get next. Now you just solve these two inequalities. You'll have 5h minus 2 is greater than or equal to 8. Well, that would just give you 5h is greater than or equal to 10. Or, now you have 5h minus 2 is less than or equal to negative 8. You would get 5h is less than or equal to negative 6. So then next, to get h, you divide by 5. You'll have h is greater than or equal to 2, or h is less than or equal to negative 6/5. And that's really all you can do. Since we have or, we have a disjoint set, so the answer to this is going to be h is greater than or equal to 2, or h is less than or equal to negative 6/5. So, if you're having an absolute value equation that is either equal to the right-hand side, or less than the right-hand side, or less than or equal to the right-hand side, you use the conjunction and then you'll set what's inside the absolute value either equal to the right-hand side and then the negative of the right-hand side, or if it's less than or equal to, you'll keep the original inequality, set that what's inside the absolute value less than or equal to what's on the right-hand side, and then you'll use the word and because you're about to get a conjoined set. you'll take the absolute value, you'll take what's inside the absolute value, flip the sign to greater than or equal to the negative of what's on the right-hand side. Then if you have a problem like this one where it's either greater than the right-hand side or greater than or equal to the right-hand side, you remember great Tor, you'll use the word or because you're going to get a disjoint set. So then you'll take what's inside the absolute value sign, set it to greater than or equal to the right-hand side, and then you'll use the word or, take what's inside your absolute value sign, flip the sign to less than or equal to the negative of what's on the right-hand side. Then you just solve from there. So that's really it for solving absolute value equations. Next lesson, we're going to go on to graphing linear inequalities, where we're going to have equations of two variables, but they're going to be inequalities. So we're going to be graphing those in the coordinate system. So I hope everybody has a good night. Take care.